today's lab, we'll do the hydrolysis of methyl benzoate into benzoic acid, which is another nucleophilic acyl substitution reaction. We'll start with the methyl benzoate. This benzoate, methyl, so methyl and benzoate. This will react with the nucleophile hydroxide. It comes from sodium hydroxide. Sodium is the counter ion, don't worry about it. Now the hydroxide nucleophile will attack the acyl carbon, the pi bond breaks, it forms a new lone pair. Oxygen already has two lone pairs, this pi bond will form another lone pair, so is the intermediate anion. Okay, so three lone pairs and a negative charge in oxide. The methoxy is still there and the hydroxy is now added to the carbon. In the next step, the negative charge or the lone pair will go back and form the pi bond, and the leaving group will leave. Here methoxide is the leaving group. The product is benzoic acid. This proton, because it's acidic, it cannot be there on the oxygen. And the byproduct is methoxide. Methoxide is a strong base, so it can remove the proton, the acidic proton, from the benzoic acid. So we cannot have this proton on the benzoic acid at this point. Right, so I'm going to remove that hydroxide. Let's remove this hydroxide and okay, this is benzoate. The hydrogen is not there, and the byproduct is a methanol. Sodium benzoate is not the final product. It is still an anion benzoate. We're going to use an acid later in a separate step to neutralize the benzoate. It could be sulfuric acid, hydrochloric acid, anything that is more acidic than benzoic acid. So let's use sulfuric acid. I'm going to simply write H plus proton, and then this negative charge takes the proton and gives a neutral benzoic acid, the final product. Take a long neck round bottom flask and check the weight. Okay, that's the weight of the round bottom flask. Note this down for your calculation. Now I'm going to add the methyl benzoate. We need 0.5 ml. Here's 0.5. Now check the weight of this methyl benzoate and the flask. Yeah, that's the weight of the flask and 0.5 ml methyl benzoate. Here is our 0.5 ml of methyl benzoate, this one. And you know the weight of the methyl benzoate from the scale. From the weight, calculate the number of moles of methyl benzoate, and that is going to be our limiting reactant. We're going to keep the methyl benzoate as a limiting reactant and use the excess of sodium hydroxide. Okay, here is our sodium hydroxide, which is a nucleophile. We're going to use the sodium hydroxide in excess, at least 4 times more than the amount of or the number of moles of methyl benzoate. I hope you have done the calculation to find out how many grams of sodium hydroxide you need to get 4 molar equivalents of methyl benzoate. So I'm going to use that weight. Probably one more pellet. Note down the weight of sodium hydroxide. Transfer the sodium hydroxide pellets into an Erlenmeyer flask. And add some DI water to dissolve it. Once the solid sodium hydroxide is dissolved in water, transfer the aqueous sodium hydroxide into a reaction flask. Here's a reaction flask. We're going to boil this reaction mixture. So let's put an air condenser and clamp the apparatus. Raise the hot plate. Turn on heating. The reaction doesn't need a lot of heating, so you don't need to time the reaction, but just let it go for a brief boiling. Add a stir bar and start spinning. The reaction mixture started boiling at about 130 degrees centigrade. So I'm going to remove the heating and let it spin at a room temperature for another 15 minutes. So turn off the heating, lower the hot plate, and let it spin for another 15 minutes. At this point in your reaction mixture, what you have is sodium benzoate and methanol. Sodium benzoate is the intermediate, methanol is the byproduct. So the next step is to convert benzoate into benzoic acid by adding sulfuric acid. After about 15 minutes of stirring, now take the reaction mixture to the next step, which is addition of sulfuric acid. Clamp your reaction mixture on a stirrer. Let it stir. Now add the dilute sulfuric acid, the 20% sulfuric acid, until the reaction mixture turns into acidic. It's still not acidic. We need more sulfuric acid. Okay, now this is acidic, right? Which means you have enough protons to protonate the sodium benzoate into benzoic acid. Transfer the product into an Olymer flask and put in an ice bath. After 15 minutes of cooling, let's do the vacuum filtration to obtain the crude benzoic acid. With a filter paper, wet the filter paper with DI water and add your product. Rinse the flask with DI water. The next step is to recrystallize the crude product into a pure one. Add the crude benzoic acid crystals into a boiling water. Let it boil to dissolve. Once the crude product is completely dissolved, turn off the heating and let it cool to room temperature before we put that in ice bath. Okay, this is the pure benzoic acid. Let's check the weight of this. That is the weight of pure benzoic acid, and here is the appearance.